Whoops. Sorry about that. I lost power there, and I was probably talking too long, anyways. But I'll just call this a part two. So let me continue where I left off because I was just about to get to the main thing, and so this is the net force. If you look at chain number one here, it's chain number one is the part that's just sitting on the ground here. So I'm going to write 0 and 0 here. There's no change in velocity, and there's no velocity to it. But this is the big piece here. Actually, this is the big one. This is the one I was kind of after here. This one right here is M2. This is the part that's in the air, and it's coming down. Excuse me. So its acceleration would be g. And then this right here then must be that additional impact that I was talking about. This right here, this term, must be what equation in step number 3 is about. Oh, and watch this. If we call this then V, I know I called it V2, but just to kind of match your problem there, let me just call it V. This is the velocity that this upper part of the chain is now moving. And then this is the derivative of how mass number 2 is changing. But if you let me go back to page 2, where we were doing densities, we said you could, write the density here as a m times an x, if you will. And so this right here, this numerator, dm, could be instead written as, well, maybe better, let's see here, this dm as rho dx. So this would be rho dx. And then, if you just let me copy this down, this right here, with the rho out in front, and it's losing mass, so that's got to be a negative. Sorry about that. And so a negative loss of mass. And then it would be dx dt, which would be its velocity. With that other velocity makes velocity squared, which makes this m2g minus rho. Oh, let me not write rho. Let me write rho as m over lv squared. Well, I probably didn't make this as clean or as clear as I'd like to, but I did want to point out this was the whole purpose, was to get this equation, mv squared over L. That is what they call number 3 in the equation. And I'm trying to emphasize it is the piece right here where the mass is being added, or in our case, the part in the air, number 2, the mass is be taken off of. In fact, that really answers what I wanted to show you, this term. Where did that come from? That's the impact term. That's the amount of force because the scale has to hit it. In fact, I kind of like to solve this for normal force and show you that if you rewrite mg here, which would be m1g plus m2g minus normal, and then over here you have m2g minus m over lv squared. And you rewrite this for the normal force. This is the force from the scale. And you realize that the stuff in the air doesn't really count. Or you can see it in the math. It cancels off. You're going to get m1g. And then you're going to get plus m over lv squared. And so this is the amount that's actually on the scale. This was equation number 2. This was the x over L, the fraction of the whole thing. And so this part right here is the impact part. And that's, I didn't realize it would take me quite so many words to get there. But that is where equation 1 and equation 2 come from. This is the force needed to hold up the weight that is actually on the scale. And this is the impact as number 2, or the second part of the chain, hits the scale. This is the impact part. Now, I guess I better stop there, but your author then just gives you then the formula and says the force as a function of time then on the chain would then be mg minus then this normal force. And so that would be xlmg and minus mlv squared. And then if you put in the equation for the x, which is where we got started, the equation for the x is right here. And if you put in the equation for the v, which is right here, you will get the force then on the chain itself as mg, and then these two can get combined together and come out to be 3m g squared over 2lt. And this is where that equation came from. Now, I hope that helped where the equation came from, but let me also emphasize, if you're just doing the problem, you could just start right here. It kind of says like this, hey, this is the given. They don't justify this term. And I thought it would be educational if you saw the justification for it, especially since we're turning a big corner going from point objects to extended objects, and you have to deal with densities and calculus, and things become a lot harder. And of course, this is the part on the scale. That one's not so hard, but that is equation 2 and equation 3, and you put them together, you get this. And then you can answer the questions just from this equation. All right. Well, I hope these two little pieces fit together really well, and all right, that's it.